Hello, welcome to another episode of the IoT webinar series. My name is Christian Henke and I'm the Director of Product Marketing at EMnify. We know building IoT products is complex, and this is why I'm inviting to every episode an IoT industry expert. The expert will give you key tips and tricks on how to solve technical challenges and how to scale your product and operation. If you like the topic or have suggestions for a new one, subscribe to our EMnify YouTube channel and leave a comment. Now let's get started. Hello from Berlin. Thank you for attending this webinar. Today we have a little bit of a different webinar format than the usual ones, which we call Coffee and Learn. We just recently had several announcements and wanted to give you the chance just to interact with us and ask specific questions around these topics. So today I therefore invited a very special guest and colleague of mine to talk about our recent announcement of the availability of LTE-M. Please welcome Nu Ho.
Thanks, Christian. Glad to be here today.
Nu has been in the low power IoT space for more than 5 years. First working at Fraunhofer that invented EMnify, a low power wide area network, and then also went to Beartech, who commercially made EMnify available. Since about 7 months, I'm really glad that she joined EMnify, and she has been a key driver behind our LTE-M announcement. Today I will talk with Nu about questions like the benefits of LTE-M, frequency bands where LTE-M is deployed, how does LTE-M stack up compared to narrowband IoT, and which service levels does EMnify provide. But actually, the reason why we do this is we want you to provide questions that you have around this technology. So please ask questions in the question panel, and I will try to intermingle these questions and we'll ask them Nu directly. So to open up the stage and as an introduction and a refresher for the audience, Nu, can you please talk a little bit about the benefits of LTE-M?
Yes, sure. So LTE-M, similar to NB-IoT, is the new 3GPP standard that falls into the low power wide area network technology. So as with many other LPWAN technologies, LTE-M provides two very attractive benefits for IoT devices and application, which are extended range and very high power efficiency. So extended range here means much better indoor and underground coverage. So just comparing to LTE or 4G, LTE-M provides actually 14 dB higher sensitivity, which means it can tolerate 14 dB higher signal loss compared to 4G. And this allows the signal to better penetrate through newer construction materials like concrete walls or fire doors and enable successful message delivery, even though the devices are located deep inside the buildings or surrounded by complex infrastructure, for example. And as for the power consumption part, LTE-M brings two new features, low power features, which are power saving mode and extended discontinuous reception. So simply speaking, these two PSM and eDirects features, they allow the devices to basically fall into sleep mode or idle mode for an extended period of time. So to save power consumption and enable a very long battery life. Another very important benefit of LTE-M is that compared to LTE, their module price is much lower. So basically, the LTE-M module price is just around 1/3 of 4G module price, which also makes it very attractive, an attractive alternative to 2G and 3G technologies, which are quickly phased out worldwide at the moment. So just a simple example of in the North America, you can see that the majority of network operators in Canada and USA have already stopped their 2G service. So this is really an urgent matter. And 4G LTE-M is forward compatible with 5G. So this means that later on, if the network operator decide to turn off 4G networks to free up their spectrum for 5G use, then your devices can still stay connected and you don't have to replace the SIM cards or go through all the hassle of certifying their devices. So those are the key benefits of LTE-M for IoT application.
Thank you, Nu, for the introduction. Hey, one of the most asked questions in the community is, how does LTE-M stack up against narrowband IoT? Can you maybe share some insights there?
Yes, definitely. It's a very common question given there are similarities between the two technologies. But I would say both LTE-M and NB-IoT have their own strengths, and it's all about mapping their network criteria against your use case and weighing which criteria is more important for your IoT applications. So let's start with NB-IoT then. So the main advantage of NB-IoT against LTE-M is the relatively lower module cost. However, if you consider that both LTE-M and NB-IoT are very new technologies, and in most cases you want to use a dual module with both technologies and also 2G form back to ensure consistent network service in multiple deployment regions. And in that case, then the device cost is basically the same, or the module cost is basically the same because it's the same type of module. The second advantage of NB-IoT against over LTE-M is that it provides a slightly better range. So if you look at the maximum coupling loss, which means the total tolerable signal loss along the transmission path, you can see that the maximum coupling loss of NB-IoT is slightly better than LTE-M, which means the signal can travel farther and can also handle better the obstacles during the transmission path. However, here you also need to consider that to enable the maximum range, you will need the maximum transmission repetitions, which then come at the cost of power consumption. So that is NB-IoT, and for LTE-M, it definitely has its own perks as well, which make it very suitable for a wide range of use cases where NB-IoT cannot cater to. First, very straightforward. The maximum data rate of LTE-M is much higher than NB-IoT, which then translates into much reduced latency. And also making it more suitable for medium bandwidth applications or application where millisecond latency is kind of required. Also, a very strong benefit of LTE-M is that it supports cell handover, which makes the technology more relevant for mobile use cases. So cell handover basically means that a device can travel from one cell to another seamlessly without losing the connection. So for NB-IoT, because cell handover is not supported, this causes two problems. So the first problem is that if the device moves to a new cell, then you will have a temporary disconnection period until the device attached to the new cell tower. And the second problem is that because without cell handover, the device doesn't recognize that it is now traveling to a new cell area and is closer to the new cell. So it will still try to connect to the old cell tower, which is getting farther away until the connection is completely lost. And this causes more power consumption because the farther the distance between the device and the cell tower, the higher the power consumption. It will raise the transmission power and also increase the repetitions. And the last very important benefit of LTE-M is that LTE-M roaming can basically be enabled over legacy 4G roaming, and then this kind of provide much better roaming, both global and national roaming availability with LTE-M. For NB-IoT, because the technology uses, like, the network operators, they have a separate commercial module, a new commercial module for NB-IoT, and the NB-IoT commercial model has yet to be very mature in roaming scenarios, and that's why still the roaming is very limited for NB-IoT between in roaming scenarios. So those are basically their key differences, I would say, between the two technologies.
Thanks, Nu. One thing that I realized is that often our customers are using the LTE-M and narrowband IoT combined module because they want to roll out in North America, where LTE-M is most dominant, and also in Europe and Asia Pacific, where there's a mix of narrowband and LTE-M. So considering that these modules support both LTE-M and narrowband IoT, is there then a difference in power consumption when using a specific technology?
Yes, so power usage is a little bit of a special case here because there is an absolute winner or loser. When you look at the power equation, there are a few factors you want to consider. So first, the usage during transmission or active mode, then the usage during idle and sleep mode, so basically PSM and EDRX cycles. And the last one is the data rate, which then decides the device transmission airtime. So what we mean with the last factor here is that the higher the data rate, the faster a message can be delivered, and then the faster the device can then switch off and fall into sleep mode to save power consumption. So just look at a real-world example of one of the most common cellular LPWAN module, which is the Quectel B95 M3 module. You can see here that according to the specification of this module, the power or the current, the current power current of the device during the module during the PSM and EDRX cycles are almost the same between LTE-M and NB-IoT. So there is no significant difference here. For active mode, NB-IoT definitely has a higher advantage here. But then if you look at the maximum data rate, you can see that LTE-M provides a much greater advantage here. So the bottom line here is that if your device just send smaller message size, which is around 5-10 kilobyte, then NB-IoT is definitely more power efficient. However, the more data you send, the more power efficient LTE-M gets. So a simple example of if you want to send a firmware upgrade to your device, and the firmware upgrade is around 2 megabyte large, then with LTE-M, it takes only 27 seconds for the firmware upgrade to be delivered, while with NB-IoT, it takes up to 5.5 minutes, which is a significant period, and a lot of power will be consumed during this whole period. So basically it all depends on your use case and the amount of data you want to send.
Thanks, Nu. I think that was a good introduction to the technology. So to the audience, if you have further questions, please use the question panel to ask any question that you have around the technology. But now, Nu, let's come to what the EMnify coverage looks like. So where can EMnify provide LTE-M service currently?
Yeah, sure. So with the EMnify IoT SIM, beside the existing 2G, 3G, 4G access that is already available, now you can also have LTE-M access in 264 networks in 44 countries around the world. Their numbers are constantly changing based on our latest internal tests and also updates in agreement with our network partners as well. So you might want to regularly visit our website to check their changes in the numbers. So if you take a look at the map here, you can already realize that the majority of LTE-M coverage is in North America and Europe, with also in some countries in South America, Asia, Africa, and Oceania. Very noticeable here also as well is that there are actually different level of coverage which then indicates a different level of certainty or insurance of the LTE-M service with the EMnify IoT SIM. So you have the expected, observed, validated, and guaranteed coverage.
Thanks, Noor. I think I would like to ask that question because we want to be very transparent when we launch the LTE-M service. Can you maybe give a little bit more insights about what does these different service levels mean?
Yes, definitely. So as I shortly mentioned before, LTE-M roaming can basically piggyback on 4G roaming because their technology is built on 4G technology, and that's why we at EMnify expect that with our EMnify IoT SIM, our customers can actually connect their LTE-M devices in regions where we have, or countries where we have 4G roaming agreements with our network partners, and then the respective network partners, they also already deploy LTE-M in their infrastructure. And that's where this expected coverage comes from. However, as you can already somehow guess, the expected coverage doesn't give an absolute guarantee that the service will be available there, and that's why EMnify takes multiple approaches to basically give our customer a little bit more confidence and in the reliability of the LTE-M service. So one of that is that we observe LTE-M devices managed on our platform to see whether there is LTE-M traffic for the respective network. And that's where you have observed coverage here. And then the next level of insurance is to really conduct internal tests for the expected and observed coverage to validate really their LTE-M service for the respective networks. And finally, the ultimate goal is to deliver really sustainable and reliable LTE-M coverage via dedicated roaming agreements with our network partners. So we basically already propose the roaming agreement, LTE-M roaming agreement with our network partners, but some of them haven't yet a dedicated roaming agreements yet, so everything is still in progress. But in the future, we expect that we will continuously expand on guarantee coverage for our customer.
Thanks, Noor. So there's a question like around this coverage map, right? So there are some more networks on this map than are actually available on the GSMA website where LTE-M is proposed. How does that come in place?
Yes, so basically network operators, they are not obliged to inform GSMA regarding their deployment, or either is LTE-M deployment, or the similar case is also with 2G and 3G phase out. So most operators will inform GSMA regarding their deployment, but not all of them actually do, and that's why on GSMA you will find fewer networks compared to our coverage map. And here we at EMnify, we work very closely with our network partners, and that's why we get these updated information directly from our network partners.
Thanks. Now let's consider if you have an IoT device and you want to deploy globally, what are the things that you should be aware of when you deploy the solution globally?
Yes. So when it comes to global deployment, there first definitely their network availability, which means then global and national roaming. So global roaming to ensure that your devices can work in multiple countries where you want them to, and national roaming here means then access to multiple network within one country to provide failover and kind of more reliability in their LTE-M service for your device within one country. The second very important factor is feature availability. For example, like PSM and eDRX, especially if low power is one of the key driver in your LTE-M adoption. The third one then is the frequency band. So what are the different bands currently used by the respective network operator in the respective countries and regions where you want to deploy your devices?
No, based on your last slide, there was one One question from the audience. In North America,
Yes,
does EMnify have LTE-M coverage on Verizon?
on Verizon.
Yeah.
So we so on I don't have the information at the back of my head, but we have the full list of LTE-M availability according to the networks on our LTE-M page. So you can already see here in the slide that there is the link here where you can access the page to really find out what are the available network that we have with LTE-M, and also the specific coverage level for their specific network.
Cool. No, this was great. So great session. I think we shared a lot of insights around LTE-M. I still want to give the audience the time to ask questions. So
Sure.
if you have any, please go ahead. Maybe one from my side, narrowband IoT support. How does that look like for EMnify? What's the story?
Yeah, so I have also quickly mentioned before that NB-IoT use a different commercial model, and that's where the roaming challenge comes from. So here at EMnify, we are working on basically their billing and charging evolution process. So this is a new type of billing model for new technologies like NB-IoT and LTE-M as well. And with that, then we can enable roaming agreement with our network partners and provide also in the future more availability for NB-IoT service. So currently we have in total around 13 networks where we have actually tested or validated or guaranteed coverage with NB-IoT, but we expect that this will increase in the future as well.
Okay, Nu, thanks a lot for these great insights. I think we are going to come to an end of this session, and just wanted to thank the audience for joining, and Nu for being such a great expert in this field. Just adjusting the camera here a little bit. Yeah, thank you for joining. I hope this answered a lot of questions that you had around LTE-M. We are always available for other questions that you have. If you want to get answer also after this webinar, you can just reach out to our support team or reach Nu and myself directly, and we will be able to answer your question. Now I want to come to already the next webinar that we planned. For that, next week at the same time and same position, I will be here talking with our developer advocate, Shruti Kuber, around our announcement of the Cloud Connect, which we have now made available in 20 AWS regions. So basically worldwide, you can directly peer with your AWS deployment. Because this is quite a technical topic, I'm really happy that Shruti will be joining me and will also do a short demo around this and will be able to explain the benefits and how this is deployed in your solution. So if you're interested to learn more, you can basically go to our website and register for the webinar. And of course, as always, you will get the recording of this webinar and some further information afterwards. One more thing before we'll close this webinar. When you close the webinar, there will be a short survey around what future topics you would be interested in or which partners you want to have invited. You know that we had, for example, AWS, STMicro, or SAF batteries here. And I would like to know who are your partners you're working with and who would you like to talk about their solution in this webinar series. And with that, I would say goodbye. Thanks for joining, and see you later. Bye.